Now let's do one example for a power cycle. In this example, we know QH, the heat released from combustion, is 1000 kilojoule. It goes into the engine. And then TH, the temperature of combustion, is at 500 K. From second law, we know you must lose heat, QC, and you lose this much heat to the environment, which is at TC, 300 K. Someone claims W cycle is equal to 410 kilojoule. Is this possible or not? And now we can use what we learned about first law and second law to see if this design is correct or not. What we need to do is to check this design against both first law of thermodynamics and second law. You cannot violate any of those two laws, otherwise your design will be wrong. So let's start from first law. First law is just conservation of energy equation. Total energy going in must be equal to total energy coming. Total energy going in is QH, which is 1000 kilojoule. Total energy coming out is QC plus W cycle. And now someone claims W cycle is 410. If that's the case, QC will just be 1000 minus 410, which is 590. So there's nothing wrong about this design in terms of first law. This design does not violate first law. But do not forget, you have to also check against second law. The second law tells us there is a maximum efficiency for a power cycle that is 1 minus Tc over Th. Now we plug in the two temperatures, 300 K and 500 K. When you plug in temperatures, make sure you always use Kelvin. It cannot be anything else. The solution will be 40%. So we know the maximum efficiency for this setup is 40%. And what is my actual efficiency? Actual efficiency is defined as purpose over cost. The purpose is W cycle for a power cycle. The cost is QH. So now we plug in the two numbers. W cycle is given as 410 kilojoule. QH is given as 1000 kilojoule. The 2 kilojoules will cancel each other, so solution is 41%. And now you can see the actual efficiency eta is actually even greater than maximum efficiency eta max. This is not possible. So after we check this design against second law, we know this design is wrong because it violates second law. So when you design any thermal system, you have to make sure to check your design against both first law and second law. You cannot violate any of them, otherwise your design is wrong.